let's look deeply into, let's break the process into two parts. As I said, there is an input. So this entire big blue box we have sliced into two parts. So as the input enters into this part, imagine you are calling up a toll-free number. At the first ring, probably you may be very lucky if somebody picks up on the first ring. So there is a queue. So there is a queue. You enter a queue and you wait for some time. And once that queue gets over, you get into the service. You actually start getting that service from the customer service desk. And once this service process also gets over, then you get the final output, right? So इस पूरे सिस्टम को मेजर करने के लिए अगेन देर आर सर्टन नोटेशंस दैट वी नीड टू अंडरस्टैंड and we'll do it mathematically and the entire case study is about this queuing theory. So R subscript A is the rate of arrival items per time. So input में किस रेट से इनपुट आपको मिल रहा है, किस रेट से कॉल्स आ रही हैं. If I were to take it from the directly from the customer service toll free number case, then किस रेट से कॉल आ रही है. So that is RA. TA is mean time between arrivals, which is nothing but 1 upon RA. Right? RA is rate of arrival. TA is 1 upon RA. Time between two calls. Time between two calls. Then CVA is coefficient of variation of inter-intervals, which means you also need to know standard deviation of the calls coming in. Right? So standard deviation upon average will give you CV subscript A, coefficient of variation of inter-arrivals. So, and B is the buffer size or maximum number of items allowed in the system. B is the buffer size or maximum number of items allowed in the system. I at one stage, I entered KFC here in Delhi, and they said it was raining heavily that day, and they had a lot of pending orders. And they said we have stopped taking the orders. And it was like evening 7 o'clock or something. And they said we have stopped taking the orders. So that reminded me of this special case of small b, which is the buffer size, that maximum orders allowed in the system. After that, I cannot take any more orders. Right? I am already overloaded till the day end or something like that. Then similarly, on the right-hand side, you have for the process RP, which is rate or capacity of the station. कितने items per time we can process, or what is the capacity, what is the maximum rate at which we can process your service request. TP is again mean process time, should be 1 upon RP. M is the number of parallel servers. So अगर आपके पास 10 servers हैं, so TP becomes M upon RP. Right? And similar to CVA, you have CVP, which is coefficient of variation of process time. So essentially what we are defining is किस rate से input आ रहा है, which is RA, उसमें variance कितनी है, और which is measured by standard deviation. Standard deviation upon average is CVA, which is coefficient of variation of inter-arrivals. Similarly, किस rate से वो process हो रहा है, कितने servers हैं, is represented by small m, and then CVP is coefficient of variation of the processing time. Right? So now इसमें कुछ हमारे performance metrics इससे निकल के आते हैं. Number one is utilization of the server. As I said, किस rate से जा रहे हैं divided by capacity, which is RP. किस rate से आ रहे हैं is rate of arrival. So RA upon RP is your utilization factor. Then TQ. So queuing time is TQ, expected wait time in the queue, and TP is your processing time. So cycle time is TP plus TQ. So which is basically your cycle time, TP plus TQ. TP is your expected processing time. TQ is your expected wait time. WIP is average work in process in the station, and WIPQ is work in process in the queue. क्यू में आप कितने लोग लगे हुए हैं? If you happen to book an IPL ticket on district, you'll see there are n number of people, and you are probably 17,000 in the queue. So there are digital queues also being formed nowadays before you can actually do a transaction. So that's another example of you waiting in a queue. And then you select your ticket and things like that, and then you finally get an output. So we see so many examples in real life. So WIPQ is basically how many people are waiting in the queue. WIP, or how many units are waiting in the queue. WIP is basically the entire box, including the queue and the service process. And CT, as I said, how much time does it take to traverse uh, from the moment you give an input till you receive an output, including the queuing time and the service processing time. And U is the utilization of the server, which is uh, किस रेट से आ रहा है और आपकी मैक्सिमम कैपेसिटी क्या है of that process, right? So how do we represent all this? How do we represent all this? So there is one very simple way, which is called Kendall's notation. Very popular and very simple. And थोड़ा सा इसको अंडरस्टैंड करने की जरूरत है. It's very simple. Initially, it might look slightly complex, but if you understand it well, it's very, very simple. So basically, it has four terms: X, Y, M, and B. X, Y, M, and B. X is distribution of inter-arrival times. हमने डिफरेंट टाइप ऑफ डिस्ट्रीब्यूशन देखा है. ये डिटर्मिनिस्टिक है, एक्सपोनेंशियल है, पोजान डिस्ट्रीब्यूशन है, नॉर्मल डिस्ट्रीब्यूशन है, या एनी टाइप ऑफ डिस्ट्रीब्यूशन. Any type of distribution. Distribution type can be anything. It can be uniform distribution, it could be random distribution, it could be deterministic, exponential, and so on. So it could be any type of distribution, but X represent की input inter arrival की distribution type क्या है, inter arrival की distribution type क्या है. Y represent करता है process का distribution type क्या है, क्योंकि आपके पास डेटा है, आप उसको प्लॉट कर सकते हैं, एंड यू कैन सी दैट टाइप ऑफ डिस्ट्रीब्यूशन. सो आपका डिस्ट्रीब्यूशन टाइप क्या है इज एट द प्रोसेस लेवल इज रिप्रेजेंटेड बाय बाय. सो एक्स रिप्रेजेंट्स डिस्ट्रीब्यूशन टाइप ऑफ इंटर अराइवल. बाय रिप्रेजेंट्स डिस्ट्रीब्यूशन ऑफ योर प्रोसेस टाइम. एम इज द नंबर ऑफ पैरेलल सर्वर्स, नंबर ऑफ सर्वर्स इन द स्टेशन, कि कितने आपके कस्टमर सर्विस डेस्क हैं या कितने आपके प्रोसेसिंग यूनिट्स हैं. And B is the system capacity at any one time. At any given point of time, what is your system capacity represented by B? So इसके चार terms हैं. Very simplistically put, Kendall's notation: X, Y, M, B. X stands for distribution type of the inter-arrival times. Y stands for distribution of processing time. M stands for the number of servers, and B stands for the system capacity. Now, how are they represented? So इसकी different terminologies हैं. For example, capital D is deterministic. If the distribution type is deterministic, you exactly know कि किस rate से आना है. Every 3 minutes it is going to come. There is a call which is scheduled every 3 minutes, every 5 minutes. So that is deterministic. So there is no CV. Variation नहीं है. Standard deviation नहीं है. It is very, very, you know, predetermined कि किस rate से आने वाला है. So here the CV is equal to 0. Or it could be represented by M, which is exponential, which means CV is equal to 1. Your standard deviation is equal to your average. Your standard deviation is equal to your average. That's called exponential distribution. So here your CV is equal to 1. or it could be represented by capital G, which is any type of distribution, which is general. You may not have D, you may not have M, you might have some random distribution, which is then represented by this capital letter G. And this represents any kind of distribution, any CV. CV value can be 0.25, it could be 1.3, 1.5, 2, anything, anything. So that is represented by capital G, right? Now we looked at some of the performance metrics in the previous slide. So U is utilization of the server, which is basically your RA upon RP. किस रेट से आ रहा है अपॉन प्रोसेस की कैपेसिटी कितनी है, किस रेट से प्रोसेसिंग हो रही है, is RP. So that is the utilization of the server. Then TQ will determine how do we calculate this, and that's a very critical term कि कितना वेट टाइम आप कराओगे कस्टमर को. CT is, as I said, the total time TQ plus TP. WIP, again, RA into CT, rate of arrival into CT, and WIPQ is equal to RA into TQ. So instead of CT, we just use TQ. Now there is this entire system. इसमें जो मोस्ट क्रिटिकल चीज है मेजर करने की, दैट इज हाउ डू वी एस्टिमेट द वेट टाइम. वेट टाइम कितना होगा. So there is this again another equation which is called the VUT equation, which is called the VUT equation, and that is what we will be using in our case study. So TQ is basically VUT capturing the variability and utilization impact. So it has basically three terms. If you look at on the right hand side, there are three terms: CVA square plus CVP square upon 2, which is basically your variability, V factor. U to the power of square root of 2 into M plus 1 minus 1 upon M into 1 minus U. This is your utilization factor for multiple servers. And TP is your processing time. Processing time generally आप आराम से measure कर लेते हो. जो processing time है, you can always measure कि कितनी देर में उसको उसकी कॉल बात स्टार्ट हुई और कितनी देर में एंड हुई, उसकी वेरिएंसेस वगैरह भी आप निकाल दो, राइट. सो एवरेज टीपी इज वेरी इजीली मेजर्ड. सो the key here is how do we estimate TQ. So there is this VUT equation that we will be utilizing. So V stands for variability, and that variable capital V takes care of both variabilities in inter arrivals as well as processing times. Capital U is the utilization of multiple servers, and T is the effective processing time, TP. Right? So if you look at this, this is VUT equation is for the general case. This is Kendall's notation: G, G, M, and infinity. G stands for any kind of distribution at inter-arrival. The second G stands for any kind of distribution in the processing system. M stands for the number of servers, and infinity is you have infinite capacity. जितना मर्जी आप input देते रहो continuous basis पे. There is no capacity limitation कि कितने मर्जी आप क्यू बना सकते हो. There is no capacity limitation or queue limitation.